This sourdough starter has developed and improved over a long period of time. Several years, in fact. It wasn't always like this. I had to build it from scratch. I built it from flour and water and turned those ingredients into something that can make bread rise and make delicious sourdough bread. This is machine learning in a jar. We're going to learn through building sourdough bread exactly how machine learning AI learns through iterations, thousands of iterations, how sometimes it forgets, sometimes it fails, sometimes it succeeds, but we can constantly develop it and improve it. This is Rose's AI, and this is baking and AI combined deliciously. Now, so far, through creating Yorkshire puddings, we've understood the three key ingredients that make machine learning AI: data, algorithms, processing power. We then built a delicious Victoria sandwich and understood something more about one of those key ingredients, algorithms, and we understood a little bit about how a neural network works, how it processes data to produce an output. Then, with our delicious ginger cookies, we understood something more about patterns in data and how the way that we train our machine learning AI through the way that we label and describe the data, through the types of data that we give it, we help the AI to build a knowledge, an ability to see patterns when it's presented with activities to complete. But it can only work with data patterns on which it's been trained, data patterns that it's learnt. Now we're going to look in more detail at that learning, how the AI actually learns through those thousands of examples, through those iterations, how it learns. So let's go back to where we started with our sourdough. I started off with 50 grams of water, 2 teaspoons of rye flour, dark rye flour, 2 teaspoons of strong white flour, 2 teaspoons of raisins for the sugar to feed the yeast on the rye flour, and 2 teaspoons of live yogurt. I mixed that all together and left it out at room temperature for a day. Now you can think about that in machine learning terms as initializing our machine learning AI, setting it off, getting it started. On day 2, with my starter, I once again added 50 grams of water, 2 teaspoons of rye flour, and 2 teaspoons of strong white bread flour. No raisins or yogurt this time. I mixed it and left it at room temperature, continuing the initialization of our machine learning in a jar. No fermentation yet, no learning happening yet. On day 3, I added 100 grams of water, 4 teaspoons of rye flour, and 4 teaspoons of strong white flour. And you can just start to see a tiny bit of fermentation. Learning is starting to happen. Mix and leave again. It takes time. On day 4, once again, we're going to add 100 grams of water, 100 grams of strong white bread flour. Now we're really starting to see fermentation. So a little bit of learning would be starting to happen in our machine learning network at this stage. But now we're going to strain the starter to get rid of the raisins, for example. So we've got a smoother mix. And once again, we're going to leave it out at room temperature. On day 5, fermentation is really starting. You get the acidy smell. If I smell my starter now, you can smell the sourdough smell coming off the starter. And that's what you start to get on day 5 when you're making your own starter. Now this time, you discard half of the starter that you're building, and then you mix and leave, you add the water, you add the flour, and you mix and leave it at room temperature. Now this is also comparable to what happens with machine learning, because we discard some of what the machine learning system has started to learn in order to try and avoid that system becoming too specialised. If you think when we were looking at our gingerbread people and our gingerbread cookies, we talked in terms of not wanting our machine learning only to be able to recognise a very particular sort of person as being a person, or a particular sort of cat as being a cat, or a particular sort of phrase as being a phrase. We want it to be able to generalise, and part of the way that we do that is by removing some of the early learning from the machine learning, in the same way that we discard some of the sourdough starter. And then fermentation really starts to get hold, and we end up with a beautiful starter that we can use to build our sourdough loaf. We end up with a network that's ready to learn, that we can start to train with the data in the way that we talked about when we were baking those ginger cookies. Right, let's get baking. In this bowl, I've got 700 grams of seeded malted flour and 300 grams of strong white flour, plus 5 grams of salt. I love a seedy malty loaf. And in this bowl, I've got 550 grams of warm water and a dessert spoon of barley malt. Again, a bit more malt flavour. And to this water, I'm going to add 500 grams of this lovely starter that I've been using for many years. This is like adding our trained model in machine learning terms. In the same way that I'm adding what's going to make the bread rise, in machine learning terms, I'm adding what's going to help the machine learning to learn. Mix the starter and the water and the malt together so that they can start working and mixing up together. You can smell the sourdough starter. It's a really lovely soury smell. And I'm going to add it to my flour. I'm just going to mix those up a little bit. Now personally, I'm not going to use the stand mixer. A lot of people do for making bread, but I actually really like doing it by hand. I like to feel the dough. I like to knead the dough. I like to get my hands into the flour, feel what's going on. So initially, I'm going to use the spoon to mix it all together. The starter, the flour together, initially with a spoon, but then I'm absolutely going to get my hands right in this. It's looking great. It's very sticky to start off with, but as it develops, you see the changes. You see it grow, you see the changes to the mixture. Okay, that's looking great. Now before I put my hands in, I tend to oil them a little bit. This is just some vegetable oil so that the dough doesn't stick to them quite as much as it would do if I didn't oil them. It's a useful tip. And then I just love hands in the dough and start mixing it up. Oh yes, it's great. So mix it all together. It's still pretty sticky, but it's starting to come off my hands thanks to the oil. I don't want to mix it too much. I don't want to overwork it, but just mixing it up so that I've got all the flour mixed in with the water and the sourdough starter and that lovely malt syrup. And I can start to see it's already starting to form into the right kind of dough. So actually I'm not going to work it much more. I'm going to take this excess dough off my hands and then I'm going to cover this with a tea towel and leave it for 10 minutes in a warm room as it will start getting to work, and then I'll come back and have another knead. Okay, so we've done our 3 lots of kneading and leaving for 10 minutes and the dough is really nice. Starting to grow already actually. So now I'm going to knead it and start to stretch it. And now I'm going to start folding it to try and get those big bubbles that we like in a sourdough loaf. Fold it, and then I turn it over, and I stretch it out, and I fold it. And then once again, I'm going to pop it back in the oiled bowl, and this time leave it for half an hour. And in half an hour's time, I will come and do that gentle kneading, stretching, folding, kneading, stretching, folding. And I'll do that twice more with an hour between each of those. So that's 3 sets of folding, the last 2 with an hour between. Then I'll be leaving it overnight, divided into 2 pieces, because this is enough for 2 loaves. And then we'll look and see what happens next. Right, before we have a look and see what's happened to our lovely sourdough overnight, let's just recap on what we've learned. When we looked at the Victoria sandwich, we looked at a neural network, a way in which machine learning AI processes data to learn. Remember, we had different layers in that neural network. We start with an input layer that receives the information. So if we're thinking about a facial recognition system, perhaps something at an airport, the input layer of the neural network would take a picture of the person standing in front of them, convert it into numbers that it would feed into the neural network, and a layer at a time, the neural network would process that information to reach an answer. Yes, this is Professor Rose Luckin standing in front of me. Tick, I've recognised that face. And if we think of that through the sourdough starter is helping us to understand how the learning happens in each of those layers in the neural network. How we build a neural network that can learn in the same way that we build a starter for our sourdough that can make the bread rise. So with our sourdough starter, we started with flour and water, a little bit of sugar through the raisins and some natural yogurt. We mixed it together. We left it to learn to ferment. We then added to it some more flour, some more water, and we left it to ferment. Of course, it doesn't ferment and learn to start off with. It has to mature. We have to build it. We then discard some. We take some away to build a stronger starter. We take some away when we're doing machine learning in order to try and make sure that the machine learning doesn't become too specialised. So, for example, that it could only ever recognise pictures of Professor Rose Luckin if we're looking at a facial recognition system. And in the end, we build a starter that can make bread rise, or we build a network that can learn. Right, let's have a look and see what's happened to the bread overnight. Oh, I can see already it's risen beautifully. Look at this. Now I'm going to very gently take it out of the bowl and put it onto the floured worktop here. Now I'm going to handle this very gently because remember we folded it into multiple layers because we want to get those lovely bubbles in our sourdough. Now this is 2 loaves and you can think of this as being a little bit like I'm baking a batch. I'm not just baking 1 loaf, I'm baking 2. And we do something similar when we're using machine learning and building machine learning systems. We help them to batch process. We don't just feed them an individual item at a time. We feed them batches of items so that they can learn. Now, not everything that's happening with our sourdough is visible all of the time. And it's true with our machine learning networks as well. Sometimes they're learning to learn, shall we say, and they can appear to plateau in the same way that for a period our bread can feel like it's not growing that much. And then suddenly there'll be a breakthrough moment, as we would call it in machine learning terms, and we get a real piece of progress, or we get a real bit of rise in our dough. Right, so I'm now going to start shaping these 2 loaves. And in actual fact, for one of them, I'm going to add something extra. Now we can think of the shaping and creating the loaves that we want to bake as like fine-tuning in our machine learning system, so that we're turning it, for example, from a general large language model to a large language model that specialises in medical information. And that's what we're doing here when we're shaping. Now I'm going to add some figs and some almonds because I love a fruity, nutty loaf. It's a friend's birthday and I wanted to take some home baking, and I thought something like a really nice loaf with some fruit and some nuts would be absolutely delightful. Put that there. Now they'll be very randomly spread through this loaf, and I'm now going to fold it in the classic folding way. A few bits fall out, but it doesn't matter. We put them back in. We turn it over, and then I'm going to fold it again, fold it over, little bit of a knead, and then round it off into a nice loaf shape. And I'm going to leave that for a final proof before I'll be putting it in the oven. Now, with the second piece of dough, I've decided to do a plait. So I've broken it into 3 equal-sized pieces, being careful not to destroy the layers that we've built up in all of that folding, and I'm now going to create a plait. So this is another version of the fine-tuning, as it were, that we would do with our machine learning network, but I'm doing it with a lovely sourdough loaf. I'm going to leave this to prove at room temperature, and the room temperature will be very warm because I've got the oven warming up to a very hot temperature for our bread. I could do cold proving and put it in the fridge, which would slow things right down. And sometimes we do something similar with machine learning. We like to slow things down, and so the learning's continuing to happen in the same way that the fermentation is continuing to happen, but it's not very visible. But I'm not doing this on this occasion. I'm going to leave these 2 lovely looking loaves to prove in the warm kitchen for about half an hour. As you can see, I've put the plait on a baking sheet. I've got the oven at 220 degrees and I'll be popping that in once it's proved and grown a little bit more. But with the round loaf, I'm actually going to use a Dutch oven. Now this is a very, very old Le Creuset, but you can turn it into what's called a Dutch oven, so you really get a build-up of heat and steam. And what I'm going to do is I'm going to place some baking paper, the Le Creuset. Then when this is proved, I'll cut some slashes in the top so that it can break open. I'm going to pop it on the baking paper and then I'll put a little bit of hot water under the baking paper, bread in, put it in the oven. Let's have a look at the finished results of our bread. Let's just test this one, see if it's cooked. It's still warm. Hollow, yes, that's cooked. And look at this one that was cooked in the Dutch oven, my good old Le Creuset. And the cuts here are not just for decoration. Look how this one's split. We've controlled the expansion of the dough in the same way that we would control what's happening when we're trying to train our machine learning network to learn. Now, this one's got a nice crust. We had it in the Dutch oven for 20 minutes with the lid on. And you can think of that as controlled testing when we're trying out the machine learning network that we've built. This is controlling the way that the loaf browns, and we take the lid off and we get the full coloration. And this is like putting our machine learning network into full production. If you listen very carefully, the loaves are still crackling because they're hot out of the oven. They're settling. And again, the same thing happens with our machine learning network. It has to settle in. It has to settle into its learning patterns. Now, one final point about this one, cooked in the Dutch oven. In that way, we were controlling the environment in which this loaf developed. And it's true when we come to machine learning. We must make sure that the environment is right, that we have the right computing resources to allow the machine learning algorithm to run. We need the right data pipelines. We need to give it good ingredients. That good prompt that you put into ChatGPT. But none of this is instant, none of this is magic. It's true for sourdough and it's true for machine learning. It took 7 days to build the sourdough starter, and then actually it's been improving and developing for a couple of years since then. And it's true with our machine learning. It might appear magic and instant when you get your answer. I stand in front of the passport counter at the airport and fairly quickly it recognises my photo. You put a prompt into ChatGPT or Gemini, whatever you're using, and you pretty quickly get an answer. But it's the result of lots and lots and lots of iterations, learning, processing, just as with our sourdough loaves. So, what have we learnt? We've learnt a lot about machine learning through sourdough. Firstly, we had to create the starter for our sourdough. We had to feed it. We discarded some. We fed it again. We built it into something that could make bread rise. It's the same with our machine learning. We had to build the learning into the network. We had to do that random initialization. We had to do that regularization, the equivalent of discarding some of the starter. And we had to keep paying attention to it. So the first thing is that it takes time. We have to iterate. We have to discard. We have to iterate again. We have to feed. We have to develop the learning in the same way that we had to develop the sourdough starter. Second point, time. Time is crucial for that fermentation, creating the right environment for the starter, the right environment for the dough to rise, the right environment for our loaves to cook. That Dutch oven environment in my old Le Creuset is important for this type of loaf. And it's the same with our machine learning. We have to create the right environment. So that's your second learning point for today. There's always 3. And the third one is that you have to keep monitoring, keep paying attention. It's never finished. My starter won't keep developing and improving unless I pay it attention, unless I feed it, unless I monitor it. And it's the same with our machine learning. We have to keep monitoring it. We have to keep checking it. So there's your 3 points for today. And remember, just as with sourdough, machine learning AI is not magic. There's a lot going on behind the scenes, both before you get to use that machine learning and when you're using it, that you might not see, but it has to be there. The process really matters. So as with sourdough and machine learning, remember, patience is key. It's not magic. It takes time. Thank you for joining me in my kitchen, and thank you for joining me on Rose's AI. Come along again. Come bake with me.